Well, team layer cake is up now with the robot already cooked in. So it seems that politics can't keep it out of robotics. It's everywhere. So why don't your team overcame tremendous problems? You want to talk about some of the dramatic failures that we've had over the month?
Well, we've had a lot of hardware problems. First, we had problems with our motor drivers. After replacing the ORC board a while later, we had problems where the computer died. Just a few. At the beginning of today, we had to replace our hard drive because that died as well. We basically replaced everything on the robot at one point.
Despite that, it still moves. It's a real testament. And also, this team were originally going with an omni-wheel design, right?
Yes, but then when our motor drivers didn't work, we thought that it was that the motors couldn't supply power to the wheels, so we decided to scrap that idea.
So very hard to give up on the design that you originally wanted to go with, but this team managed to do it just to be able to produce a robot that would work at all at the time. And it seems that you have an active gate. So do you lift up as soon as you see a ball, or?
And I think that maybe because it doesn't appear to be at all.
So where are we looking here to see what this is?
Right now it's up against the wall.
So the one, it looks like you've coded it. So the one labeled with webcam, the blue is, I'm assuming, showing the ground, and the brown is showing the walls?
The black is the walls. Yeah, the photo camera. We never actually got a chance to take pictures in this room, so.
Well, you've seen something. Slightly off. I'm looking closely at your wheels. It seems like you have sandpaper?
Yes, that's so we can get more friction and slip.
So what is this goal right found at, and then it gives some XY coordinates and an angle? Talk about that a little bit.
So basically that means it's seeing a goal. There is no because of the calibration. And that's basically the side of the goal is seeing the approximate angle that we have to
And then it looks also like we have some sensor output readings. And as you can see, there's just a tremendous amount of complexity associated with the robot. Each and every one, right? There are all kinds of values, and the failure is often very hard to diagnose exactly where the problem is occurring. So are you keeping track? Does it think it has a ball or ignore goals that it sees if it doesn't have one?
It shouldn't think it has a ball because I don't think it's ever been qualified in mode. Basically, every time it gets into ball capture mode, rather, it increments the count, and it does assume that it won't get every ball that it tries to pick up, but there is a limit that it will try for. So.
Then again, though, your exploration seems to have done a very good job. And you started off there, looped around, came to here, and now looked back. So I think you've covered just about every area of the course.
Yeah, we're just doing wandering. It basically goes in the direction where there's the most distance. We have a lot of IR sensors, which help us do that.
what exactly are the IR sensors doing for you?
Basically figuring out how far away the walls are, keeping us from. So actually, like what it's doing right now, for example, this is just the IR sensors telling it to do things, because we actually wrote a panic mode, and I thought we were using it because we were getting out of these sorts of situations, but I looked at the code earlier today, and it turns out we're not actually using our panic mode. So.
So does it think it sees something right now? It seems to be wandering back and forth. And also another topic that a lot of teams have used a bit of control theory. They use feedback in order to improve upon the results. Are you guys using that in your detection at all?
Not really.
So I don't know if it's possible for audience members to see, but there actually is a ball more or less directly in front of it, so it's having a little bit of trouble, it seems. And has the robot stopped? All right, well, fine run for Hillary Clinton. Thank you very much.